can you see a time in the near future when our door-to-door deliveries will be UAV? Are we close to this?
To be honest, yes. And the way in the past 5 to 10 years, the way the UAVs have developed, and let's face it, the drone delivery in the USA, it's already happening with the Amazon and some other couriers. For example, like DHL, I know they're doing it. I don't see why not. It's more of just making the regulatory needs that in the urban areas, there are certain routes and things like that to make it possible and safe. Because I think safety should always be the first priority in all of this.
Welcome back to KU Pulse, the podcast. My name is Dr. Glenda El Gamal, and I'm a senior lecturer in the General Education Unit here at Khalifa University. And before we start today, I'd like to remind you about the latest edition of Khalifa University's Science and Tech Review. It's called The Heat is On. And if you'd like to read a digital version of this, you can access it online at kustreview.com. And now let's welcome our guest. It's my great pleasure to welcome Alex Janković, and he's the head of research and development at AirQ at Masdar City here in Abu Dhabi. Welcome.
Thank you so much.
So let's get straight into it. What inspired AirQ? Tell us what it is and the vision.
So the AirQ was inspired, I would have to go back to the story of our CTO. And he used to do a lot of UAV design in his previous life. And he wanted to come here and to start doing something and to make a change for the better and to build something that it's completely different and unique, and it will actually serve a purpose in the UAE.
The UAE is heavily involved and committed to aerospace engineering. So tell us where AirQ fits into that.
So the AirQ started off building smaller UAVs. So the purpose of the UAV was to make it a modular platform, so you could actually scale it and build on top of that and integrate it into different purposes. And now we found the purpose to expand even beyond just one platform and to increase the product range and create some sort of a family, as we could, if we can say like that, and basically provide an aerospace field for the young engineers to test their crafts and to make an impact in the world.
The magic word impact. We often hear about this whole idea of innovation with impact. What does that mean to you?
Creating something that it's purposeful and is actually being used is much more impactful than just doing some innovation for the sake of innovation. So the whole idea, but if you can merge now those two things to blend them together, where you have innovation that can be used at a certain point of time, that's beautiful. And that's where you get the impact, the innovation, and the whole satisfaction of the two.
So with you, we have the marriage of industry and academia. Can you tell us something about the collaborations that you have at Khalifa University and AirQ?
Yes. So currently we are working with the Khalifa University, and we're having two projects with the Khalifa University. The first one being working on how to make the acoustic sound of the UAV lower. And the second that we are working on is the cloud seeding project, which the idea is to completely automate the cloud seeding in the UAE. So I can expand now on both if you would like.
Yes. Well, first of all, let's talk about that acoustic footprint, because to a layman, when I think of UAVs, I think that noise.
Exactly.
So what's the solution for this, and where are we heading with this?
Yes. So like you mentioned, if we were to think about regular noise of the UAVs, we always can consider the constant buzzing sound like a mosquito. It starts to resemble like a mosquito. It can be a little bit annoying and uneasy and not pleasant to be around.
So what's the solution?
So the solution is I can go back a little bit and explain when we design, for example, propellers, we design to have the best efficiency, not keeping acoustics in mind. So, but when you start to merge the acoustics, the design of the propeller, the edges of the propeller, the tips, the specifically how the propeller creates vortices, which are turbulent air around the propeller that is being created. Once you start going into that, that's what actually creates that pitch, that sound. But if you can alter that in small variations, so you can shift the frequencies in some range where it's less disturbing for the human, or you just the decibel levels are getting lower. That's the whole idea of the noise being lowered.
And the cloud seeding, tell us about the cloud seeding.
So the cloud seeding, that's very interesting so far. The way it's been done, it's very, I would say, human involved. And the idea is try to automate things, which we have a lot of research going into that. And that's why we're collaborating with the Khalifa University for that part, because they're doing a lot of the heavy lifting on that side. The idea is to take the equipment needed for that and not have just once you go up there, you do, and then you have to buy another equipment. The idea is to keep reusing the whole system and to have a mission type that the whole UAV can go up there, do the necessary, and then come back and land safely, and basically repeat it to many extent as it's needed.
With cloud seeding, that opens up a whole area of ethics, doesn't it? About decisions about when and how. Who gets to decide that, and who should decide that?
So from my point of view, I strongly believe that it should never be one-sided. And that's why I think a collaboration between the industry and the university, and in the end, the government itself, I think those three entities should work very closely together to understand how and why they should do certain things. If it becomes one-sided, it can become a little bit of, maybe, I wouldn't use the word unsafe, but it can go in a direction maybe not pleasant for some other parties, I would say.
So you're looking at a whole 360 of all the parties involved and whose interests are being served.
Exactly. And when we say interest, it's not necessarily the interest of just one side, like you said. So it's a 360. We have to understand what every side wants to achieve. And we have to understand from, for example, the Khalifa University as the science behind it needs to understand what's the impact of doing such things. So the whole idea is, yes, we have a common goal, but we cannot just go and do things how we please. We need to understand what we're doing and what impact we're making.
I'm thinking now about climate. You're originally from Serbia, a very different terrain, very different climate. When you came to the UAE and started doing research here, what challenges, what modifications did you need to make to adjust this technology to the fairly harsh desert environment?
Yes. First of all, you're completely right. The climate in Serbia is completely different. We have 4 seasons like in Europe. Basically, it's Europe. And we have a lot more rain, snow, and mixed with hot summers. In here, the main difference is that we don't have rain as much, but we have a much harsher summers, meaning it gets way hotter than in Europe, for example.
And how does this impact the technology?
So it impacts in a way that you have to cool the equipment down. That being said, sometimes it's not as easy because, for example, when you're building a UAV, you want as small of a footprint as possible. You want to be as lightweight as possible. For the components and the heating element inside the components, they want the opposite. They want robustness. They want to be big. They want to have big heat sink. You need to dissipate the heat in the air. And the main thing that you have to think about, the ambient temperature, which is certain degrees, let's say 50 can get here, and then the equipment that it's been worked on. For example, the controller for the motor can rise up to 50 or 60 degrees. For example, if it's 60 degrees, you only have the delta temperature of 10 degrees. Cooling that down with a delta 10 degrees, it's very hard if it cannot go beyond that. But for example, in Europe, when you have degrees as 20 or 25 as nominal, your delta T is much greater. So that's the main thing why components we have to choose for here needs to be much bigger so they can withstand the heat, and we can dissipate the heat fast enough so the UAV can safely fly and land for a certain amount of time.
It sounds like you have to do quite a lot of experimentation before going through that. Can you tell us about some stories or incidents where you had to test the technology in this way?
Actually, we have to test most of the critical components on the UAVs before we even commit to the first flight. That being said, okay, you first need to confirm everything is working on ground and in the office or facilities at the climated area. Then you need to go outside. We're still talking about the ground tests. And then you test them on the ground, seeing how the temperature affects, seeing where you constantly basically look at logs. You want to understand from logs where the temperature levels, we basically stress test. We have a way of stress testing. That's a way of testing that the vehicle should not experience in the flight itself, but we want to test the limits to understand, for example, if we want to put the motor to run at 100%, and we see what the temperatures are, but we know that it's the same thing as running a regular at 80 or 70% of throttle only. So when we go to the first flight, we don't have a catastrophic failure or something like that.
So there's a lot of risk assessment involved.
Always. And you have to be aware of those things. Otherwise, you will go. You will bump into trouble. That's for sure.
Oh, I don't want to be bumping into anything, do we?
Of course.
Can you see a time in the near future when our door-to-door deliveries will be UAV? Are we close to this?
To be honest, yes. And the way in the past 5 to 10 years, the way the UAVs have developed, and let's face it, the drone delivery in the USA, it's already happening with the Amazon and some other couriers. For example, like DHL, I know they're doing it. I don't see why not. It's more of just making the regulatory needs that in the urban areas, there are certain routes and things like that to make it possible and safe. Because I think safety should always be the first priority in all of this.
What about the role of AI? There's always discussion about the sweet spot between human
Yes.
intervention and machine autonomy. Where is that sweet spot?
So, as you had just asked the question, multiple things actually came to my mind, and maybe I can start from the basic engineering point of view and the basic design of the UAV. For example, the way the UAVs and in general aircrafts are being designed as of now, we take a starting point and then we iterate. Basically a team of members go in and iterate on the design and try to approach at the different angles and to see how to design the aircraft to serve a specific mission as good as possible. Or if it's a multidisciplinary, you have to think about all the different con-ops that you're doing. But with the AI, you are now in the era where you can leverage for some of the cases. In some cases, more than the others, there are tools now that you can use in the design, and the iterative process can be much faster, and you can converge much faster to the point where you want to get than you would do with traditional ways. So that's part in the design. For example, the second part can be in the con-ops where you want to plan a specific mission. And we as a human beings, even though we say we can multitask, we can actually do only one operation at a time very good. When we start to multitask and think about many different things, it can become hectic for us. For an AI, that's not a problem. That's what we need to use it for. And for example, if you're planning a mission, instead of looking at different variables that can happen in that mission, AI does that automatically and can much faster generate a much optimized route. And depends, are you looking for efficiency? Are you looking for fastest route? And I think the best way to make a connection to this, if you ever used Google Maps, and I'm pretty sure you did, this is the point where it can give you, this route is a little bit slower, but it saves you 5% of emissions. This route is the fastest, or this route has the most crowd, and but it's the shortest. Depending on what you need, you can choose. So that's the beauty of the AI implementation in the technology.
This is good to know. It's an optimistic future, embracing
Definitely.
AI. Well, Alex, many of your projects have societal and environmental impacts, and they hit the UN SDGs, SDG 9, SDG 13, and SDG 17 in particular. So, how would you say you balance innovation with sustainability? And what about sustainability? You're based at Masdar City, very big on sustainability. Tell us that nexus of AirQ and sustainability. How do you see it for the future?
Yes. So, for example, to start off with, our UAV, if we're talking about Harara, it's purely electric. And of course, there are some limitations with the batteries. So we switched to having also an option with a hybrid system. But primarily, the propulsion system is chosen to be electric for a reason. First of all, being it's very versatile, it's very efficient. And the third thing is, as the technology of the battery progresses, so does the performance of the UAV. So it's, I would say, future-proof. How you may ask the question, yes, but we still need to get the energy from somewhere. And if we just go back to the point what you just mentioned, is that Masdar City as itself, it's very self-sustained with the solar panels and other technologies. This is still on the ground level. So you need to source the energy from the ground, put the energy potential into some unit, battery in this case, and you put it on a plane and then you go in the air. On the same topic, for example, one of our products is the electric launcher, which is using the same concept of electricity, converting from electrical to mechanical energy to launch the UAVs itself as well.
So we know that UAVs have the capability of high-resolution sensing and surveillance. So how do we balance that capability for surveillance with the individual's need for privacy?
Well, we have to think about first thing that where is that video stream going? So is it being kept on the UAV itself? So is it being used that the UAV can detect the terrain and monitor and understand its surroundings? Or is being transmitted to other places, for example, like a central hub, that it's being used for recording or other things? If we are talking about the privacy, of course, one of the cases that we will have to consider, like I mentioned already, the routes that we have to have for a certain delivery and for surveillance have to be pre-selected not to have any privacy issues. And if there even are, we have to have a consent, of course. So that's one of the things. And the other thing, like I already mentioned, is that if the video is only kept on the UAV for its temporary sake, it's not being recorded, it's just being used for monitoring on it, basically to understand the terrain, what is around it, then that video is not being used for anything else. So it's very secure, and even we don't know what it sees. But in the end, even in that case, it's predefined route, and even if there are some cases where it cannot, we have to have a consent if we want to go over a terrain that we need to film or do something in that regard.
So in all cases, it's informed consent and
Yes.
always very mindful
Yes.
of privacy issues.
Yes, always.
So what potential do you see for UAVs to be used for emergency aid or logistics or humanitarian response?
In my point of view, UAVs have a tremendous place in this regard, because we mentioned that we have the drone delivery, let's say, or UAV delivery in some cases. This falls into that category where, for example, you're at one hospital and you need samples of blood or other specific things that it's very time sensitive, and you need to transport it in a very secure environment, certain temperatures, humidity, and things like that. And you need to transport it in very like half an hour, but the traffic is really bad. You need to go from Abu Dhabi to Dubai, let's say. So in this case, using a UAV to do that job, which it can do in 30 minutes or so, let's say, that's a very welcome thing. So in that case, that's only one case. But in second case, for example, if we take into account that we're saving a life, for example, and we need a fast delivery of whatever equipment it may need at that point, either to a hospital or to a specific terrain, where it's very hard to reach, for example, then we're talking about the category where we're having an impact on human life. And the last thing I would mention is also if we think about organ transplant, which is a very sensitive thing, and you have to transport it, like I mentioned, to a very temperature and humidity environment, and you cannot let the organ sit for a certain period of time without being used.
It's crucial.
It's very crucial, and in that regard, using something like a UAV to transport it very fast and use it at a specific place, it's life-changing.
It is life-saving and life-changing.
Exactly.
And what about the weight that a UAV could carry? I could imagine circumstances where they'd need to carry tons. What would be the limits?
So in our case, for example, the current product that we have can carry only 6 kilograms, which falls in the category of smaller payloads. But like you already mentioned, this can be scaled into hundreds of kilos or maybe even tons at some point. And as of now, the technology of scaling to the hundreds of kilos is already there. If we're talking about the electric and the very specific, I would say, not conventional takeoff and landing, more of a vertical takeoff and landing. But if we talk about going conventional and we're talking about advancing the technology, I really don't see a limit of carrying even tomorrow tons with the same method.
Exciting indeed.
Yes, I agree.
At Khalifa University, we are training the next generation of leaders and innovators like yourself.
Yes.
So as someone highly involved in the field and successful, who's making an impact, what's your best piece of advice for engineers and scientists who are interested in this field?
One, I would say there are multiple, but if I have to choose one, this is a very fast-paced and a competitive field. And if you want to dip your toes in it, you have to start learning and keep learning and just don't stop. Because as soon as you stop, you will be left behind. Just keep learning daily. Whatever you think you know, just go online, buy a book or something. You will find out that you still have a lot to learn.
So it's a journey, not a destination.
Absolutely. And it's a lifelong journey, I can tell you that.
A lifelong journey. So on that lifelong journey, what is next for AirQ?
For AirQ, we have a lot of things prepared. And for now, I would say the primary thing of the AirQ is to scale even more, to be as sustainable as we can in the future, and to expand the opportunities in the aerospace field for the UAV, and to give the opportunity to the young people to make that change and make the difference in the world.
Thank you, Alex, for your very informative discussion on UAVs and AirQ. And thank you for joining us on KU Pulse, the podcast.
It was my pleasure.
And if you'd like to be a guest on our podcast, you can contact us on ku.ac.ae/KU Pulse.